So hello and welcome everyone. My name is Jadal Sania, and in this video we are going to solve the problem that is left view of a binary tree. Okay, so before starting the video, let's keep a target of 15 like in this video. And if you are really enjoying this video solutions provided by GeeksForGeeks, then do hit the like button and share down your approaches in the comment section below. So without wasting any further time, let's start the video. So in this question, you are supposed to find the left view of a binary tree. So what does it mean? So it means that you will be given a binary tree and return the left view of it. So left view of a binary tree is basically means that let's say you are standing on the left hand side of a binary tree. So whichever nodes are visible from the left hand side from top to bottom of the binary tree, print them in the output. Here you are supposed to return the list of all the nodes that are visible. So that's what the question is expecting you to return. Okay, so let's see an example over here. In this, you will be given the binary tree. Like let's say this is your binary tree given to you, and if you observe from the left hand side, you can observe 1, 2, 4 and 8. So the left view of this binary tree is 1, 2, 4 and 8. Okay, similarly we can see the example number 2. In the example number 2, from the left hand side I can observe 10, 20 and 40. So that's the left view of the binary tree. So I hope you have understood what the problem is trying to say. Return the left view of the binary tree. Okay, so now let's try to understand how we can solve this question. So here what we will be doing, let's take a dummy binary tree. Let's say you have 10 over here, you have 30, you have 20, you have 40, you have 50. Okay, so this is the binary tree, and let's say this is our input number 1. So now in this input, or let's say in this binary tree, how can we find the left view of it? Okay, so that means that you are supposed to observe the left hand side of the binary tree, and whatever is observable, then you are supposed to find all those nodes. Okay, so there is a trick in solving the questions related to binary tree or graph. So if you want to think about any approach, start with the traversal technique. So here in binary tree we have in order, pre-order, post-order, that is depth first traversal, right? And then we have breadth first traversal, which is called as level order traversal. So here if you go depth first, right, basically you will be going into the depth, but here you can observe. First of all, let's see what will be the output of it. So if you observe the output of it, you can observe that from the left hand side 10, 30 and 40 will be visible, hence the output comes out to be 10, 30 and 40. Okay, so can you observe something? So let's say you have some levels over here. Let's say this is the level number 0 of this binary tree, this is level number 1, and similarly this is level number 3. Okay, so let's say this is level 0 and level number 2. So here what can you observe in the output and the levels that I have mentioned over here? So you can observe that on each and every level you can observe this is this node 10 is present at the level number 0, and that is the first node that you observe from the left hand side. Similarly, you have 30 in the output, and 30 is the first node of the level number 1 that is present on the left hand side. Similarly, we have output 40, and 40 is the first node of the level number 2. Okay, so here I can observe that if I go by level order traversal, then whichever nodes are observable from left to right hand side in the level order traversal, whichever is the first node, that is going to be my left view of the binary tree. Okay, so we are supposed to traverse level by level. Okay, so now let's say we are using level order traversal, and we know that in a level order traversal we will be taking help of a secondary data structure, and that is our queue data structure. Okay, and this queue will be storing the nodes, the actual nodes, so that we can reference their left and right child. And now let's say for storing the answer, we have something called as answer list. Okay, so I'll say here is your answer list. So this is the list that will contain the answer. Okay, fine. So along with this, what I will be keeping, I will be first of all, let's start the iteration of the level order traversal, and then I will show you what you are supposed to do. But along with this, let's say I have a size variable. Okay, and then along with this I will be having a flag variable. So flag will be always initialized with true value. Okay, and what does this flag indicate? So flag indicates that whatever node that you have removed from a queue, is it the first node of a level? Yes or no? If the flag value is true, then whatever node that you have removed is considered to be the first value of the level. Okay, and along with this I will be having a current node. Okay, so what does this current do? Current basically removes whichever node is removed from the queue, that will be stored inside current. Okay, so now I'll start the iteration. So let's say this is the root, and the initial step of this binary tree level order traversal is inserting the root node. Okay, fine. Okay, so I have inserted. Now there will be some iterative steps that will keep on continuing, right? So now what I will do, first of all, before removing, I will extract the size of this queue. What is the size? Size indicates 1. So why I am extracting the size of the queue? Because here you need to identify that when are you switching from level 0 to level 1 and from level 1 to level number 2. So what I did, I removed the size of the queue. So this size indicates that whatever nodes are present, this many nodes, size number of nodes are a part of a particular level. So here size indicates 1. So 1 indicates that there is a node 1 present and that is part of some level. Okay, which level? It does not signify which level, but it signifies that this many nodes, size number of nodes are a part of some level. Okay, fine. So I can see size number of nodes are there. So I will be extracting size number of nodes because they are considered to be the part of the same level. Okay, so one more thing, flag will be initialized when you extract the size of the queue. So flag will be initialized true. Okay, so now I will remove size number of nodes from the queue. Okay, size equals to 1. So size is greater than 0. So I'll remove 10. So current node is what? 10. Okay, fine. So now when you will insert the current node inside our answer, when the flag value is true. Is the flag value true? Yes, the flag value is true. So that means the current node should be inserted in the answer. Okay, fine. And after inserting the current node, I should reverse or change the value of flag to false. Why? Because only one node of a level will be included in the left view, and that is the first node. So we have included 10 in the output. Okay, fine. Now what to do with this current? Check the left and the right child of current. So 10 has 30 in the left hand side and 20 in the right hand side. So first of all, I will insert 30 and then I will insert 20. Okay, so this size value will be reduced by 1. So now size is equivalent to 0. So when the size is equivalent to 0, that means you have iterated over one of the level. Okay, so now again reinitialize the value of size. Okay, so if you reinitialize the value of size, flag value will also be initialized. Okay, so what is the value of size? Size is equivalent to the number of nodes. How many nodes are there inside a queue? It is equivalent to 2. And flag will be initialized again with a value called as true. Now I will iterate over size number of times because this indicates that there are 2 nodes and they are part of a new level. You can observe 30 and 20, and size indicates two nodes are there that are from the same level. Now let's remove a node. So let's remove 30. So I'll be removing 30. Okay, fine. Now check the value of flag. Flag says true. That means this is the first node of a level. So insert 30 in the answer. Okay, fine. And then simultaneously, after inserting 30 in the answer, change the value of flag. So flag will be now equivalent to false. Now what to do? Insert the left and the right child of this current. So 30 as left child as 40. So I'll insert 40 over here and I will insert 50 in the queue as well. So I've inserted node 40 and 50. Okay, fine. Now I have removed one node, so size will be reduced by 1. So size will be equivalent to 1. Now again check the value of size. What does size say? Size says whatever level you were iterating, one node is still remaining. Okay, so remove one node. So 20 will be removed and 20 is considered to be the current node and size will be reduced to 0. Okay, now check the value of flag. Flag is saying false. That means current node is not the first node. Okay, so 20 will not be printed in the output. So now what to do? Check the left and the right child. So left child is null and right child is also null. So if left and right child or any of them is null, we are not going to insert null inside of a queue. Okay, fine. Now we can observe the size value is again 0. So this indicates that you have iterated over one of the level. And which level have you iterated? So you have iterated level number 1. Okay, fine. So again reinitialize the value of size. So flag value will also be reinitialized. Okay, fine. So size will be what? Equivalent to the queue size. In queue there are 2 elements, so size will be equivalent to 2. Flag will be reinitialized to true. Okay, so now remove size number of elements from the queue. So 40 will be removed. Now check the value of flag. Flag says true. So 40 is the first node of the level order traversal. Okay, fine, of this particular level. Okay, now simultaneously change the value of this flag to false. So flag will become false over here. Now check the left child of 40. It is null. So don't insert null. Right child is also null. So don't insert null in the queue. Okay, fine. Size will be reduced by 1 because you have removed one node. So 40 was removed. Let's remove 40. So now again do the same thing. Is the size value greater than 0? Yes. So I will remove one node from the queue. So current will be 50 and size value will be reduced by 1. Now, is the value of flag true? Flag is equivalent to false. So this means that you are encountering a node that is not the first node of a level. So 50 will not be inserted in the answer list. Now check the left child of 50, it is null. Right child is also null, so don't insert null in the queue. Okay, fine. So now you can observe that size value is already 0. So now we have removed 50 from the queue. Now again reinitialize the value of size. But here you can see that nothing is present inside the queue. So size will again become 0. So this means that when your queue becomes empty, you have done or completed your level order traversal. And whatever is present inside the answer list is your output. Okay, so here basically what we are doing, we are doing the iteration by level order traversal, and whenever we encounter a new level with the help of size variable, we will be printing that level first node in the output. So that's it. Okay, so I hope you have understood what the approach is. Now let's jump to the implementation part and let's see the implementation part for the same. Okay, so here I have implemented the entire thing in Java, but same can be implemented in other languages as well. So this is the left view function that we are supposed to complete, and root has been given as the argument. And here you can observe this is the list of integers or the left view. So here I have created a list that will be storing our answer, and I'm calling it as answer list. Then I need a queue for our level order traversal, so created a queue. And as we know that the first initialization step of level order traversal is to insert the root node. So I have inserted the root node. Now until my size of the queue is greater than 0, I will first of all extract the size from the queue. This indicates how many nodes are from the particular level, are from the same level. So I will extract the size, initialize the flag to true, and then I will extract all the nodes that are part of the same level. That while the size is greater than 0, I will remove the elements. Okay, fine. So now I will remove an element. So current is my node. Now I will check the value of flag. If flag is true, then first of all I'll make the flag as false, and then I will insert the current node in the answer list. Then I will check the left child. If the left child is not null, insert the left child. If the right child is not null, insert the right child in the answer list. And at the end, you're supposed to simply return the answer list. So now let's try to click on the submit button and let's get this question done. And we can see that the problem has been successfully submitted. So here if we analyze the time and space complexity, so the time and space complexity, so let's say time complexity. So the time complexity is equivalent to the order of n, because here you are iterating over each and every node, or traversing over every node only once. And how many nodes might be there? N number of nodes. So time complexity is order of n. And now if I talk about the space complexity, the space complexity says that we are going to store some answer in the output. So that will be also equivalent to order of h. Order of h basically means the height of the binary tree. So you can call the height of the binary tree as n as well in case of a skewed binary tree. So you can say the space complexity is order of height of the tree or order of n, that is total number of nodes. So that was it, and that was it from my end. So here you can also consider the queue data structure as well, because queue is also being used, and at any instance it's possible that there will be n number of nodes in the queue data structure. Okay, so the time and space complexity comes out to be linear, that is order of n, and we have completed the solution of left view of the binary tree. So that was it from my end, and if you really enjoyed this video solution, then do hit the like button. So till then, I will be meeting you in the next video. Till then, keep coding. Bye bye, and thank you everyone.